ladies and gentlemen, this is Nature of Sound and correlates with chapter 15.1 in your textbook. Your key concepts and vocabulary for this video are: what is sound? What three things influence the speed of sound and how? And then to define and explain density. Hopefully you remember density from earlier in the year, but we'll briefly review it just in case. Now let's talk about what is sound. Sound is a mechanical wave, and it's actually a longitudinal mechanical wave, which means that the particles vibrate parallel to the direction of energy transfer. So you've got those compressions where they're squished together and those rarefactions where they're pulled apart. And so, for example, as this young man is hitting the drum, it's causing the air particles around it to compress together and then stretch out and compress and stretch. And as they compress and stretch, that's how sound travels. So that is what sound is. Now, there are three things that influence the speed of sound. One of them is temperature. Another is stiffness, and a third is density. Now let's first talk about temperature and sound. Now, as temperature decreases, the speed of sound also decreases, which means that they are directly proportional. So think about it this way. In the summertime, when it's warmer, sound travels faster because it's warmer. Whereas when it's wintertime and it's colder, sound travels slower. Now, stiffness and sound. As stiffness increases, speed increases. So, these are also directly proportional. Stiffness as in like the firmness of something. You can also think of this in terms of the states of matter. For example, solids are the most stiff out of solid, liquid, gas, whereas gases are the least stiff. So sound travels fastest in solids and slowest in gases. Now we've also got density in sound. Now just so you remember, density is the amount of matter per volume. We can remember that by drawing the heart. The top is the mass divided by the volume, and so that's our density equation. Now for density, as density increases, speed decreases, which means these ones are inversely proportional. Now, you can think of this, it's a little confusing because density, you think, well, density in the states of matter, but if it's the same state of matter, something that is less dense will travel speed faster than something that is more dense. For example, lead and steel. They're both solids, but lead is more dense. The particles are closer together than in steel, where they're a little bit further apart. So because the particles are so close together, it's actually hard for them to be able to vibrate and pass that sound. Whereas steel, they're close enough together that they'll vibrate and pass the sound, but they're not so close that they're going to stop it from traveling as easily. So in this case, the lower density affects the speed of sound and making it go up, whereas the higher density makes it go down. That's it. Please make sure that your notes cover all the key concepts and vocabulary. If you need to review any of it, go back and watch that section of the video again.